Welcome back to Learning with Ms. H. Today we're going to look at our lesson for Earth Science on relative age dating for rocks. Your bell work here is to answer in your notebook, how is relative age dating useful in determining the history of the Earth? And there's a little bit of information up here above it about how this works. So relative age dating helps geologists figure out when events occurred in the geologic record in relation to each other. It doesn't give us an actual date or age of the rock, but it tells us rock A is older than rock B. So it puts things in order, or it sequences an order of events. So how would that be useful? Go ahead and pause the video here, answer that question in your notebook, get your materials out and together to take notes with, and then we will move on. All right, welcome back. Today's lesson has 3 parts. We have a presentation and then a short video and a practice assignment so that you can apply what you've learned. So we're going to start off with our presentation. Remember that when we're taking notes, you can go ahead and pause the video to finish writing on a slide if you need to, and then start the video again to move on. Because I do go through these relatively quickly so that the video doesn't take an hour for you to watch unless you need it to. So we're going to start off by looking at what is relative dating. We have 2 ways of dating rocks, relative and absolute. Relative dating is going to put things in order or sequence of events. So when did things happen in relation to each other? It's the basis of our geologic time scale, but it does not give us a true age. So it will not tell us rock A is 50 million years old, but it will tell us that rock A is older than rock B. Absolute dating does the opposite. It is actually going to give us a true age, a number. So we will know that the fossil or rock or crystal that we are looking at is X amount of years old. So we get an actual number from this. You need a very small sample of the material, usually not more than a grain of rice sized sample. It's going to be organic tissues or crystals. So organic tissues are going to be things like minerals and bones. And what we're looking at here is the amount of unstable isotopes that have decayed. What does that mean? That means you have basically a radioactive element in the rock, or some type of isotope of an element in the rock that is not completely stable. You can lose pieces of that element over time, and it turns into something else. That is a very pared down way to explain it, about as basic as you can get. So you lose atoms from the element until it turns into something else, and then you measure how much of each of those elements you have in order to figure out how old it is. We will get more into absolute dating in a future lesson. For right now, we are going to really focus in on relative dating. So there's a couple of principles that you need to know for relative dating. Law of superposition, cross-cutting law, law of inclusions, and law of original horizontality. These are 4 things that you will use to show the relationship between 2 or more materials. So first off is the law of superposition. Basically, it's going to give the age of rock layers, and it's going to tell you that the oldest layer is at the bottom, the youngest layer is at the top. It makes sense because when you lay something down, you're going to lay it on top of whatever is there. So whatever was laid down first is going to be near the bottom, whatever is laid down last is going to be near the top. So law of superposition shows that oldest is at the bottom, newest is at the top. That's it. Now, if you've got something that's been disturbed, disrupted, that's going to mess it up. So if you've been digging here, you may not be able to use law of superposition because you've kind of mixed all the material up. But if you have a sample that has not been messed with in any way, this absolutely works. Again, relative dating just gives us a relationship. So this is perfect for this because you have oldest and newest. That's a relationship. You can put those in order. So, examples of law of superposition that do not relate to geology. If you have a school locker and you throw something in there, and then you come back a couple days later, throw something else in there, a couple days later, throw something else in there, everything you throw in gets thrown in on top. So the stuff you threw in first is at the bottom, the stuff you threw in last is at the top. So oldest is on the bottom, youngest is on the top. Here's an example of superposition in some rock layers with some different fossils. So if you're looking at fossils, you would be able to tell me that the fern leaves in layer 7 are younger than these organisms in layer 1, but they are older than these bones in layer 11. So you have to look at where it's at in the column. Oldest is on bottom, youngest is on top. Number 2, the cross-cutting law. So any feature that cuts across a body of sediment or rock is younger than the body of sediment or rock that it cuts across. What does that mean? That means if something's cutting across something else, the something else is the older, and the something cutting across is the youngest. So in this image, you have this little sash right here is cutting through all of these layers. All of these layers had to be here already in order for this new thing to cut through it. You can't cut through something that does not exist. So everything that's been cut through is older than whatever is cutting through it. So you know that this has to be younger than all of these other things because it's cutting across them. So this is the youngest. And then if you take that away and just look at what's underneath it, you know that all of this is older than this one. However, then you go back to law of superposition. So the oldest is on bottom, the youngest is on top. So this is the oldest, this is the youngest. However, this is older than this because it cuts across it. So if you were putting these in order with the oldest as number 1 would be down here in this solid white layer. Number 2 is this dotted layer. Number 3 is this solid layer. Number 4 is this one, and number 5 is this one. Cross-cutting igneous rocks happen because you have things like magma chambers, lava flows, lava plumes. These things can go through other rocks, other layers, and that's what basically happens here is you have a chamber down here, the batholith down here, and you have these plumes coming up, and then you have another chamber and some plumes. So these are going to come up, eventually they're going to come out through this volcano, but all of these rock layers that they're cutting through are going to be older than this rock that's coming up. So the orange is going to be younger than all of the rock it's cutting through. And then this image on the right is showing you what that actually looks like in a real world rock sample. So these dark stripes here are cutting through this lighter rock. So the darker stripes are younger. So law of inclusions. Rock A is the orange, rock B is the brown. If something is embedded in something else, the rocks that are embedded are always going to be older than whatever they're embedded in. These guys can't get trapped in something if they don't exist yet. So all of this orange down here has to have existed before this brown because the orange is inside the brown. So even if the brown comes down like this and you have like a pool of brown here where it's oozing over, you know that the orange is still older because the orange is up here inside the brown a little bit. Here's an example of that. You have this lighter colored rock on the outside. You have this darker colored rock on the inside. That means this darker colored rock has to be older than the lighter colored rock because it's embedded in it. Law of original horizontality and lateral continuity. So this is basically saying that layers of sediments are originally deposited horizontally. They fall to the ground and they land horizontally. So even if this shifts a little bit and it's no longer horizontal, so it tips up on its side, you can still see the layers and you can tell how they laid down. And they should be equal on either side of this canyon here. And here's an image of horizontal layers in Marble Canyon, Arizona. It's called Marble Canyon because it kind of looks like there's marbling in the rocks here with the different layers. So again, you have younger on top, older on bottom, and it's laid down in layers horizontally. This canyon on the right, you can see equal layers on both sides. So in this image, this rock has shifted. There's been some kind of event here that has tilted it up almost to a 90-degree angle here. So it's flat over here, and then it tilts up here. So something has happened to move this rock layer so that it's no longer positioned horizontally. This can be things like erosion, earthquakes. It could indicate a fault line. You could have human interference if we dug through this area and then just shoved everything off to the side. There's all kinds of things that can affect this. If you are out in, for example, the Grand Canyon or any other area with these pillar type events happening, if you look across these, you should be able to see the equal layering all the way across, almost as if somebody just took a chunk out of it. Okay, so a disconformity. This is anything unusual, unexpected, things that don't belong. So if you have an angular disconformity, younger segments are going to rest on top of the eroded or tilted section. So what we've got here is a section that is older. It is no longer horizontal. So it may have laid flat originally, but it got tilted up on end. So it's raised up here, and then other things have been laid down on top of it. So these guys are younger than this stuff down here, even though this stuff is at an angle. So your oldest is here in the lower left of this top image, all the way up to this layer here is younger, and then these on top are even younger still. So this one's younger than this one, and this one on here is the youngest. So that is an angular unconformity. A disconformity means you have younger beds connecting up with older beds. So you have uneven surfaces here. So this kind of cuts down through here and touches this older bed. So this one is going to cut through, so it is going to be younger than this one. And this is generally indicative of erosion on the surface. And it's usually irregular erosion. Paraconformity means the beds above and below are parallel and there's no real erosion evident, but there's a definite gap in the rock record there somehow. So you have a couple layers here, and then you would have a missing layer, and then a couple more layers. And nonconformity means that you have sedimentary rock and older igneous rock or metamorphic rock that's actually exposed to erosion. So this is going to be somewhere where you've had erosion move rock away, and some of the older rocks are actually exposed and eroding also. I highly recommend sketching these images into your notes along with your version of the explanation, something that makes sense to you and explains that picture. So again, as always, make sure that you are pausing the video as needed to copy some of these slides down. I know some of them are going to take longer than I give you. Basically, the disconformity means a boundary between two non-continuous rock ages. So it means some type of unusual erosional surface, and the boundary is usually not smooth. It's very irregular. We're going to take a look more closely at some of these. So angular is when it's tilted on its side here, and again, The one on the bottom is the oldest. So this guy is going to be the oldest down here. This guy is going to be the youngest up here. You know that because it takes really less effort to tip it back to the right to make it horizontal than it does the left. So you have these layers on bottom that are tilted, and then other stuff gets laid down on top. Here's your non-conformity. You've got these weird, not smooth borders between your layers. So for relative dating, you need to take a look at this image and put the layers in order from oldest to youngest. Anything that cuts through, remember, is younger. These lines here where you have the shift happening, that's going to be a fault line. So the letters that look to or represent that fault line are going to be younger than the rocks that fault line cuts through, just as if it was another rock. So take a look at this and see if you can put these layers in order. All right, hopefully you figured out that this A down here is the oldest. The little letter A is right here. It's also right here. It's this layer that's underneath this thing. And that's part of the fault line right there also that caused this shift to happen. So A is the oldest. Then you would have this letter. So this layer. Then you have this kind of brick layer. You have this purple layer. This beige layer. This dark brown. Then you have the blue. Then you're going to have the fault line going through. So that's the H, the fault line going through all of that. And then all of that shifts with the fault line, and that's what causes it to tilt. Then you have this layer J coming in on top of it. I represents this unconformity layer here. So you have the letter J coming in on top. Then you have this letter K brick layer here. Then you have your blue dashed layer here. Then you have your kind of salmony colored layer here coming through and cutting through all of this stuff below it, including this fault line. On top of that, you have this brown spotted layer, and you know that the pink layer is older than the brown spotted layer because you have these inclusions right here. Then you're going to have Q come in. And then you have this guy, this dark brown with the spots here. That's going to be younger than Q, but it's going to be older than this reddish layer here because it does not go through that reddish layer. It only comes up through the Q. So it's going to cut through all of this stuff. So it comes next. Then you have this reddish layer. Then you have this purple lava flow layer. And then you have this top layer here. And that should be it. So here is your lettering, your key for the order here. All right, so relative dating. This is a really complicated one. The ones that you're going to do are a lot more simple than this, but this gives you a little bit of everything included in it, including the introduction of the fault line, and kind of makes you think about all of your principles all at once. Your homework assignment is going to be a little bit less intense than that. You're going to come down here and watch this video about relative dating, and then make sure you pause me, watch this video. When you're done with this video, you're going to do your assignment down here. So you're going to click this document to read it. This is information on how to do your relative dating assignment. So this is going to give you instructions. It's going to go through the purpose to learn how to do relative dating and recognize those geological events, why we do it, where it comes from. Your principles are all listed out here again. And then you have your examples. So you're going to tell me what is the oldest, what is the youngest, put them in order. So for figure A, rock A is the oldest, rock D is the youngest, put them in order. Example 2, you're going to put these in order. A is the oldest, followed by B, C, D. Then you have E coming in on top and F coming in on top of that. Number 3, you have rock C here. And we just have a little snapshot, not the entire picture. You have rock C is the brick, rock B is this light colored with the spots, and rock A is this darker colored with these little slashes in it. So it has rock C as the oldest. Can you guys guess why? Hopefully you notice that there are little bits of rock C inside of rock A, so C has to be older than A. But then you have B cutting through both, so B has to be younger than both, which means B is on top for the youngest. C would be on bottom as the oldest because of these inclusions, and A would be in the middle. So that's your quick explanation. Your assignment, if you click on the relative dating assignment, you have one of the NOC quizzes to complete, and you are going to answer these questions and put things in order. So you're going to actually apply what you've learned about relative dating. So make sure that you've done the lesson already. If you're coming straight to this, you're not going to be able to do it. But this is a NOC quiz. You can do it as many times as you need to, and you're going to take each one of these images and you're going to put the layers in order from oldest to youngest by doing drag and drop. So you are going to do that for all of these images. Just drag and drop, put them in order. So there's several on here. They increase in complexity. And then when you're done, hit submit, and then you are done for the day. Hope you have learned a lot about relative dating, and we will see you next time.